A lifetime of hard work, children laughing in the kitchen, family photos on a restaurant wall, a legacy that lives on. It all comes from the power of a conversation, like the one Tommy Hall had with First Horizon Bank about taking over his father's Charleston-based restaurant business. Now the table is set for a whole new generation. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Tommy. First Horizon Bank, member FDIC.
Big decisions require research. So if your teenager is considering a decision as big as joining the military, they're doing their homework. You can too, by visiting todaysmilitary.com, because their success tomorrow begins with your support today.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining Space Nuts, the astronomy podcast where we talk about nutty space stuff. And joining me as always is astronomer Fred Watson. Hello, Fred.
How are you doing, fellow nut?
Freezing. I'm freezing. I know people in the Northern Hemisphere who are going through summer will laugh at me because their winters are so much more severe than ours because they get, snow. But we had -7 here last Sunday, which is the coldest on record. And that broke the record that had been broken only 2 days before, that had broken a record from 2002. So we've had a real cold spell. There was ice on the lakes at the golf course, which has never been seen before in the history of Australia. I mean, it was just dreadfully cold. You were here and you didn't even say hello.
No, we were passing through very rapidly. So just for our international listeners, Andrew, -7 Celsius is 19.4 degrees Fahrenheit, just so that everybody is kept happy.
Yeah, and now they're laughing at me.
Yeah, they are.
Yeah, when you trick them with Celsius, that's fine because they go, oh yeah, that sounds pretty cold. But no. But the thing is, as you know, we've just come back from Europe, and when we got to England, we were freezing, and they thought it was positively balmy. It's all relative, isn't it?
It is indeed. That's right.
And when it got to 21, they were freaking out because it was so hot, and we just laughed. Well, shoes on the other foot now. Now, Fred, today we're going to be talking about some new moons that have been discovered at Jupiter, which surprises me, might surprise a few people. And something we've alluded to a couple of times in recent weeks is this upcoming lunar eclipse, which should be pretty exciting. It's going to be quite a spectacular one. And blazar jets. Someone sent in a question about those because of all the discussions we've had in recent times about black holes. So we'll get on to that. But the new moons of Jupiter, what gives, Fred?
Complete accident, actually. Not the moons themselves, but their discovery. So it's one of these cases where astronomers were looking for something else, and they found something different from what they were looking for. So this is with a telescope in Chile called the Blanco telescope. It's very similar in size and shape, actually, to our Anglo-Australian telescope, the 3.9-metre telescope at Siding Spring Observatory in northwestern New South Wales, not that far from where you live. But the Blanco telescope is, as I said, a similar telescope in Chile, and it has this extraordinary wide-angle digital camera. So it's a bit like the camera in your phone, only about 1,000 times bigger.
Yeah.
And that's used actually for all kinds of survey work. And in particular, the astronomers who were using it, a group from the Carnegie Institution, were looking for very distant solar system asteroids, things out in the Kuiper belt there, beyond the orbit of Neptune, the place things we call trans-Neptunian objects. Mm-hmm. We know that there's a whole belt of asteroids out there. There's about 1,000 of them known. Pluto is one of the bigger ones. It's one of the reasons why Pluto was reclassified as a planet, as a dwarf planet, back in 2006. So they were carrying out a survey looking for these things, but suddenly realized that the planet Jupiter was not very far away from their field of view. And they suddenly started picking up moons of Jupiter, moons of Jupiter that were previously unknown. And these are really interesting ones. So they've discovered 12 new ones. That brings the total number of moons of Jupiter that are currently known to 79.
Wow, that's a lot.
It is a lot. Yeah, when I was a lad, we thought Jupiter had 12 moons. That was it. That was all new, with the very best telescopes in the world. Now we've discovered 12 more on top of 67 to bring the total to 79. But they're really interesting ones because they, first of all, most of them orbit a long way from Jupiter. They've got periods of rotation. I beg your pardon, periods of revolution about Jupiter, let me get the terminology right, of about a year. In fact, some of them more than a year. So really slow-moving objects quite distant from their parent planet. But another group of them, or one of the significant groups of these moons, are in what are called retrograde orbits. That means they're going backwards.
Oh, really?
Yeah. So in the solar system, pretty well everything, not entirely everything, but most things, if you looked at them from above the North Pole, they'd be going anti-clockwise. That's the preferred direction of the solar system. And we've talked about why that should be before. That's the fossil rotation of the swirling gas cloud from which the solar system formed. But several of these, I think something like 9 of them, are going around in what we call prograde orbits. I beg your pardon, what we call retrograde orbits, which are backwards, and that means they're going clockwise. I know that sounds counterintuitive, but clockwise is backwards in the world of astronomy.
Yeah.
But intriguingly, there is one little fella, and this object is no more than a kilometre in diameter, so diameter is probably the wrong word for it. It's probably just a lump of rock, which is it's in a prograde orbit. What that means is it's going the right direction. It's going anti-clockwise, but it's right in the middle of this bunch that are going the other way.
Oh my word!
Yeah, it's named Valetudo, or Valetudo. This is Roman mythology. It's one of the daughters of Jupiter and the Roman goddess of hygiene and personal health.
That just proves beyond reasonable doubt they're running out of names.
Yeah, well, yeah, it proves that the Romans had too much time on that.
That's true too. Who can we worship this week? Oh, what about hygiene? Let's go for that.
Hygiene and personal health. Next week we'll do toothbrushes. Yeah.
Oh dear. Well, that's a good one.
So the bottom line with Valetudo is that it might not last very long because it's in the middle of this swarm of things coming the other way.
So there's a chance that, I mean, you said it was quite small. There's a chance that it was bigger at some stage by the sound of it.
Yeah, that's exactly right. In fact, that's the theory, that perhaps all we're seeing is the last bit of debris of something that was much bigger and basically collided with these objects coming the other way. Wow. So yeah, very, very interesting stuff. We are intrigued to find that Jupiter is still producing surprises. When I saw this news story the other day, Andrew, I was at first sight I thought, oh, this must be from the Juno spacecraft. It must be a discovery made by Juno, but it's not. It's made by Earth-based telescopes, and I think it's pretty neat that a telescope in Chile can spot something a kilometre across at a distance of 500 million kilometres away. It tells you just how sensitive modern astronomical detectors are and how effective they are at picking up these distant things. And of course, they're detected through their motion through space. That's how you find objects solar system objects generally tend to move in front of the background of stars, albeit not very fast. But it was the motion of these moons that picked them out as moons of Jupiter rather than just stars in the background sky.
And yet Juno, which is right there, didn't see any of them. But then again,
no, partly because it's not looking for them.
Yes. And it
focused very firmly on the planet itself is Juno.
Yeah, it would have failed the gorilla test. Do you know the gorilla test?
Just remind me.
This was a test. I actually fell for it
that's
myself.
right. It's another one.
Where you're told to watch something that's happening in front of you.
Yeah.
And while this is going on, a guy walks through in a gorilla suit, and then they say, "Did you see the guy in the gorilla suit?" And you say no, and it shows how selective your brain is in interpreting data right in front of your face. And I watched this on a documentary on TV, and when they said to the audience that was in the studio how many saw the gorilla, about 3 people put their hands up, and then they showed the video again, and I went, "Oh my God, that's a gorilla!" But I never saw it.
So obvious. That's right.
So Juno failed the gorilla test.
I have seen that. Yes.
But have they given names to all of these moons?
I'm not sure about most of them. Normally with moons like this, little objects, you basically give them numbers.
The Astronomical Union's going to be going crazy. They haven't been as busy for a long time.
Yeah. I haven't seen a list of the other moons, but just going back to maybe their origin, it seems very likely that
Captured?
Yes, exactly.
Oh, I'm getting better and better at this.
I'd say no more. because they, the group that are going retrograde, going backwards, they're almost certainly captured objects that Jupiter's swept up as it's been passing through clouds of cosmic debris, of which there's not very much left because it swept most of it up.
And that's right. That's one of the doctrines of space. Don't mess with Jupiter.
I think that's right, yes.
Yeah. Get too close and that's the end. Yeah.
There's a signal coming from Jupiter there. You can probably hear it.
Yes, indeed. Yeah. So we'll probably learn more about this as they now arrange studies of these objects, because and how many more might there be? That's
that's the other question. That's right. We as instruments get more sensitive, we'll find more of them. It's like the Earth. Potentially Earth-damaging asteroids. As instruments get more sensitive, we find more of them.
Yeah, and I suppose I'm going to preempt an audience question here, because someone will say, could this be how the rings formed? So, could this be how the rings formed?
Yes, possibly, because the rings of both Jupiter and Saturn, actually all the giant planets have got rings. Of course, the most prominent ones are Saturn's. Jupiter's are a bit faint, as are the others. But they are almost certainly... I mean, the jury's still out, but I think it's fairly well. It's the standard model that these formed from something that got too near, and the tidal forces of the respective giant planets just pulled them to pieces, and so you get this ring of debris. What's interesting about the rings, though, and particularly rings of Saturn, is how narrow they are in a sort of vertical direction, because the gravity of the planet just pulls them into this shape where they are like a blade of debris flying around. They're only 100 meters thick or something ridiculous like that.
Yeah, it makes some beautiful pictures, though.
They do indeed, absolutely.
All right, we'll keep an eye on the new moons of Jupiter, and who knows what else they'll find by accident in the not too distant future. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by Tech Radar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons, and there was just something about their business model that I particularly liked, and a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Next, Fred, we're going to talk about an upcoming eclipse, which has got a lot of people excited because I've seen some press reports suggesting it will be the longest and reddest blood moon lunar eclipse for a long, long time. But it's certainly got people chattering. That's certainly a definite. But what is special about this one, if anything?
Yeah, it is special. No, you're quite right, and for the reasons that you've said. So what happens in a lunar eclipse? Well, the moon passes through the shadow of the Earth, which is streaming out behind us in the direction opposite to the sun. The shadow of the Earth at the distance of the moon is roughly 3 times the moon's diameter. So the moon itself is a quarter of the Earth's diameter, but the deepest part of the shadow at the distance of the moon is about 3 times the moon's diameter, and that's because the shadow is actually a cone. It's a very, very long, thin cone, and that's because the sun is not a point source of light. If the sun was a point source, the shadow would just be parallel, but because the sun's got its own angular diameter, then the shadow is a cone. So at the distance of the moon goes through a shadow that's more or less 3 times as big as the moon itself is. Usually when we have eclipses, the moon sort of either skims through the shadow off center, or sometimes it only barely skims the shadow. But this time it goes pretty well right through the middle. And that's what makes it a very significant eclipse, because as you can easily figure out, if it's going through the middle of the shadow, it's going to be one of the longest eclipses possible. And so this is that sort of thing. I think it's about 3 hours altogether. It's quite lengthy. So we will see this in Sydney, and probably just to give you times for Eastern Australia, which is the easiest way to do it, even though I know many of our listeners are spread all around the world, but all of you have access to local internet services that will tell you exactly what the local times and local circumstances of your eclipse is.
GMT plus 10.
GMT plus 10 hours, that's right. That's correct, yeah. So I
know that because of jet lag.
Yes, of course. Which you're still suffering from.
No, I'm pretty good now. Took over 2 weeks.
Yeah, that's right. It's a lengthy thing, especially coming back this way from west to east. Anyway, never mind.
Yeah.
In Sydney, the eclipse is in the small hours of the morning of the 28th of July, which is next Saturday week. Our time as we speak at the moment. So 28th of July, small hours of the morning. And in Sydney, in fact, the eclipse starts the bit that's important, what we call the partial eclipse, when the moon starts going into the deepest part of the Earth's shadow. That starts at 4:24 a.m. And totality, which is when the moon is completely within the Earth's shadow, but not yet in the center of the shadow, that's at 5:30 a.m. And then the maximum eclipse, 6:21 a.m. Sydney time, by which time it's kind of starting to get light. So
yes, it is.
It will not be quite so obvious, but it should be a pretty dramatic blood moon in those small hours of the morning of the 28th. Elsewhere in the world, you've got probably more convenient views. It looks as though in Africa, in particular, it will be probably before midnight. It'll be late in the evening, but certainly not anywhere near as inconvenient as it's going to be here in Australia. So it should be a good eclipse. Yeah.
So this will be in our western sky, I assume.
Indeed, that's right.
Yeah.
because the sun
is rising.
Yes, the sun is rising. That's correct. So it's in the western sky, the moon's setting. So just to give a quick rundown, it's visible pretty well throughout the world, actually, one way or another, apart from North America, I'm afraid. The North American continent and Greenland won't see anything of this eclipse, but Africa, Asia, Europe, South America, and of course Australasia will get good views. So assuming the skies are clear, that's always the caveat with these things. There's no point in going looking for a blood moon if there's thick cloud overhead, because it's a bit of a waste.
Well, we've had some fairly clear nights this month, being winter, and it's the driest time of the year. So we have a lot of clear nights, and they get rather frosty, as you know. But if this was a weekday, I'd be able to get up and see this, because I go and do a radio program every day, and that's about the time I'm out and about. So, but it's a Saturday, and I sleep in on a Saturday, so I'm not sure, given the current conditions here, that I'm going to be struggling up to have a look at this one.
Do you know? Neither am I. And that's just sheer laziness. I'll tell you though, Andrew, there was a total eclipse of the moon in, I think it was January. It was earlier in the year, and I was night observing then on the telescope, and the skies were clear where I was up at Coonabarabran, and it was really very spectacular. And what's really, I guess, striking about it was I had to, in the middle of the eclipse, I had to wander from one building to another, and just walking across a landscape very familiar to me, at a time when it's full moon, and the full moon is in the sky, but it is blood red, and all the stars are shining. It is a very peculiar experience. The moon takes on an almost ethereal quality, and it's sort of there, but it's abnormal, and it does look really freaky. And just the fact that the sky is dark, and so the stars are all visible, that really enhanced the effect of that.
And you know what's going on. So imagine how the ancient people would have reacted to something like that.
Yeah, that's right.
Yeah, they would have thought there was an apocalypse coming or something. And this one's going to last, as you said, quite some time, which makes it extra special. Just one final thought: can we learn anything by observing a lunar eclipse? I know we can learn a lot about the sun by looking at a solar eclipse, but does it translate the same way with a lunar eclipse, or is it just pretty?
No, you can do. And in fact, it's a really good way of sensing the condition of the Earth's atmosphere, if you see what I mean. Because what's happening, that blood red colour comes about because the Earth has an atmosphere, and so the light of the sun is scattered through the Earth's atmosphere around the edge of the disk of the Earth, if I can put it that way. And the red light that you see on the moon itself is the kind of sum total of an entire, basically one sort of hemisphere almost of the Earth. It's not a hemisphere, it's that ring of light around the Earth that you would see if you're standing on the moon. But it's a fairly global phenomenon. So if there's lots of dust in the atmosphere, or lots of cloud in the atmosphere, that will affect the colour and intensity of the blood moon. So people do study it. Scientists do study it and look for some of these phenomena.
Speaking of which, Mars is quite spectacular in the sky at the moment. You can see the redness of that planet. I believe there's a dust storm on Mars at the present time, which is making it so much more vivid in our night sky. I've seen it the last few nights. It stands out like, I won't use the Australian vernacular, but it stands out pretty significantly. It's
hard to miss. And in fact, it's now brighter than Jupiter, which is the other bright planet in the sky. Jupiter's almost overhead. Mars is rising in the east in the early evening, and Saturn is between them. So you've got a brilliant show. In fact, if you look out fairly early in the night, Venus is setting on the other side of the sky. It's absolute bonanza for planet watchers.
Absolutely, indeed, yeah.
In planets.
and you won't have any trouble finding Mars at the moment. I mean, it's just really lit up like the top of a Christmas tree.
Vivid red coal.
It is indeed, yes. We'll probably talk about these things again in the not too distant future here on Space Nuts. Andrew Dunkley and Fred Watson, of course.
3, 2, 1.
Space Nuts.
Finally, Fred, and this seems to be a bit of a trend for us now, we talked about something the other day and got avalanched in questions. So the topic is black holes, and we were talking last week about being able to see one for the first time. We know they exist. All the mathematics and evidence suggests that they are there beyond reasonable doubt. But we have never actually seen one, but it looks like we were getting pretty close. I don't know if that's happened yet. I did see a story the other day that suggested we might, but they might have been alluding to the possibility rather than the fact that it's happened yet. You might know. But it's prompted a question from Mark Bealey. Hi, Fred and Andrew. Here's my question. If nothing can escape a black hole, how do those blazar jets manage to escape? And how do they form in the first place? Many thanks. Love your informative and entertaining podcast. Thank you, Mark. We appreciate the positive attitude and the great question, Fred. Really good question.
It is a good question, yeah, and it's one that crops up quite a bit. But specifically in this case, it's referring to a news story actually that we didn't really cover. It is connected with black holes, and it's some neutrinos, which are subatomic particles that have been detected by a marvelous neutrino detector at the South Pole called IceCube. An IceCube is a 1 cubic kilometre array of detectors that are looking for the flashes of light that are produced by these subatomic particles as they interact with the ice. And so IceCube has detected a burst of neutrinos, and their source has been traced back to an object that we call a blazar, to rhyme with quasar.
Yes.
Blazars, when I was a young astronomer back in the 1970s, we called them BL-LAC objects. BL-LAC is the name of what was thought to be a star, a variable star. In fact, that's the nomenclature in the constellation of Lacerti, which is why LAC is the abbreviation. And BL-LAC objects were weird things that seem to vary in brightness and emit a lot of energy. And we now know that they're sort of related to quasars, but slightly less violent. And what we believe is happening here is that there is a supermassive black hole, and these can be of the order of 1 billion times the mass of the sun. They're very big ones in the center of a galaxy. And that black hole is absolutely gobbling up material around it. And so that's where this is where Mark's question comes from. Nothing can escape a black hole. And yet we've got something that is emitting copious amounts of radiation. In fact, that radiation, a lot of it is beamed from the poles of the black hole, the rotation poles of the black hole. So what's happening here is you've got a huge disk of debris swirling around the black hole. And in doing that, it is highly energized because of collisions. That causes it to emit X-rays, and that's actually how we know that this accretion disk is present, because it emits all this radiation and radio waves. But near the center, near where the stuff disappears down the plug hole, if I can put it that way, you encounter a region where there are incredibly strong magnetic fields. And these are generated by the black hole itself. So, forget the magnetic field of the Earth. These are hugely more powerful magnetic fields. And it's the effect of the magnetism that beams out the jets of material from the north and south poles of this swirling disk. They act like particle accelerators because of the magnetism. And basically, the disk material, some of it is not going in the black hole. Some of it's being focused out into space. And actually, if that jet of material points towards the Earth, then you've got a blazar, basically. That's how it works. So the jet of material is directed in the Earth's direction. You see all this radiation, and it's coming from things that are being changed in their direction by the magnetic field around the black hole. So something similar happens actually on a smaller scale, Andrew, with neutron stars, things called pulsars, which are jets of material that come from the poles of neutron stars. Neutron stars are not black holes, but they're not very far off becoming black holes. They're the size of a city, but with the mass of a star in them. So they're incredibly dense. That's right.
I just so struggle to comprehend that kind of situation.
We're not really equipped to do it.
No,
right.
And I think another similar thing is something the size of a coin that weighs as much as a car, and that sort of stuff. That
yes, that's right.
It's just a weirdism that I suppose because we've lived on Earth and everything is sort of relative to where we are. We constantly think in terms of what we know. And so when someone says, well, if you're on this planet, this is what happens, nah.
Very different. So neutron stars also have these magnetic fields. They also beam material out near their magnetic poles. And if the neutron stars are rotating, what you get is this sort of lighthouse effect of the beam. And that is what causes pulsars. And pulsars are very topical for us at the moment because the discoverer of pulsars, Dame Jocelyn Bell Burnell, is in Australia as we speak. She's giving a talk for us tonight, which by the time most of your listeners hear, that'll be too late to book in for. But check her out on the web. She's a very distinguished person. She is a dame of the British Empire.
Wow.
So very, very, very high accolade indeed for the discovery of pulsars. So that's how the blazars work. It's a similar process, but on a much more giant scale than with the pulsars. And if you've got this, as I said, if you've got the stream of material being accelerated by the magnetic fields pointing towards Earth, that becomes a cosmic beacon, which we call a blazar. We used to call them BLAC objects, but blazars sound a lot more interesting.
They do indeed, yeah. I still struggle to understand these things sometimes, but I hope, Mark, we managed to answer your question adequately, and we certainly do invite questions. We try to get to them all. Sometimes they come in great big truckloads and it's hard to nail them all down, but we do try to pick the ones that are topical enough, or there's something in the news about them at the right moment. So hence your 15 minutes of fame there, Mark. Well, actually no, 7 minutes 7 seconds, but so we still owe you some time. But please keep in touch with us via Facebook or Twitter or any of those platforms that we were on. We really do appreciate the feedback as well. Sometimes people just message us, Fred, to say hi, which we also appreciate. And I do try to answer people when I can. If you do get an answer on Facebook, it's usually me being a dimwit. As always, Fred, thank you so much. Greatly appreciated. And we will talk again very, very soon.
That sounds great, Andrew. Thank you for your time, and we'll speak soon. Yeah, bye for now.
Fred Watson, astronomer, and from me, Andrew Dunkley, thank you as always, and we'll catch you next time on Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.